It seems like it won't be fitting down the stairs into the basement.
No.
But it was worth a shot.
I'll have to go through the bulkhead.
Okie dokie.
I'm gonna need your help for that.
Okay.
Sure.
So, what is that?
Tank? Buffer tank?
A buffer tank. Currently empty, not very heavy.
120 pounds.
It currently weighs 120 pounds?
Yeah.
You're just moving around like it weighs nothing. Bye. What am I doing?
I need your help.
What am I gonna do?
We're gonna get it down the stairs.
How am I gonna help you?
We're gonna carry it.
Okay.
I'm gonna mount all of the major components, pumps, manifold, expansion tank, all that sort of stuff. It's gonna be mounted to this piece of plywood here. And I'm gonna mount the plywood on this wall. Is how do I attach a sheet of plywood to a rock wall? I could do anchors. I have like Tapcon screws that I could sink into some of these larger stones. I don't really want to do that. So what I'm going to do is I've got some 2x4s here, and I'm going to attach the 2x4s up to the timbers and have them resting against the stones and screw the plywood into that. And then, so the whole thing will basically be hanging from the floor structure. And then I may brace it on the bottom as well, like back into the wall, but we'll see how sturdy it is. There is going to be a fair amount of weight hanging off of it, so I want to make sure that it's nice and sturdy. So the whole thing is mounted, suspended off the floor, suspended off the wall. The right side I think is pretty good. I think I'm gonna brace this back here. You see there's a gap, and this wants to wiggle a little bit as I push on it. So I think I'm gonna cut like just a piece of 2x4 just to kind of wedge in there and hold it in place. But I think this will work. I have the majority of the components mounted to my board here. The outdoor unit, the heat pump itself, will output hot or cool water depending on the season, but let's assume that we're heating the house. So hot water will come out and will come into here. I have a air separator with a expansion tank, and then this here is a glycol feeder. So this tank will be filled with my glycol mixture. I'm going to run 30% glycol, propylene glycol, and this will maintain system pressure and automatically refill as needed. If I have a small leak somewhere, this will kind of allow me to see that leak. The level will go down over time, and I mean, ideally it wouldn't do anything, but this is kind of an aid to keep your system pressure where it needs to be, because this is a closed system. Nothing is really connected here yet. I'm just mocking it up. I have a swing check valve that I know is mounted 90 degrees from how it should be, but like I said, it's just mocked up. A temperature pressure gauge right here. So I've got my fill purge valve here. So the way this works is you can close this valve and it basically diverts the flow through these connections here. So when I fill this with glycol, I'll do that and I'll fill it. I'll fill the tank and then, let the air purge out. And then when it's all good, I can flip it over and close these off. So it'll come out of here. It'll go into my tank. I think it's going to go in to the tank right here. Got to think about that. The tank is an 80-gallon composite tank. It's insulated. This is the thermal well where my controller will read the tank temperature. The tank has a drain down here. It has an air vent up here. The purpose of the tank is for thermal mass, so that the heat pump does not short cycle and can, run as efficiently as possible. So then it'll come out, I'm going to say on this side, connect back over to here where I have a dirt separator, and then my circulation pump for the heat pump loop. Another pressure temperature valve or gauge. Basically, this will give me the pressure drop across the heat pump, and from that I can estimate flow rate. I was gonna put a flow meter in, but it's too much pressure drop, the one that I got, and I don't want to restrict the flow that much. If I somehow come across a lot of money, I may put one in down the line, but for now we're gonna have to estimate based on the curve. This will also get me the temperature, the delta T that the heat pump is providing. So with delta T and flow rate, I should be able to estimate the amount of heat energy, in BTUs or kilowatts, that heat pump is providing to the system. The other half of the loop will have water coming out of the tank. We have a pressure relief valve. Water will come out of here, pressure relief valve, and then connect over to the dirt separator. For the distribution side, water will come out. This is a spring check valve. The reason I put a spring check valve on this side and I have a swing check valve on the other side, this will prevent thermal flow because there is some minimal pressure required to open this up. So water will come out of here, connect over to my circulator pump for the distribution loop, and then go into my manifold. Initially there's actually going to be 3 zones. I need to cap this one off, but I could have up to 6 zones on this manifold. Temperature here, going up to the system, and then I've got my returns here. There's a flow meter built into each return, and then temperature there as well. And then this will come out from here and return back to the tank over here. So that's my 2 separate loops. I've got all the fittings taped up, ready to go. I've just made my first PEX connection. This is the first project that I'm using the Pex-A like expansion type fittings. I think I may have just changed a little bit how I want to run the pipes, how the flow would work. So this pump here is going out to the outdoor unit. So this is pulling from the tank, and then here is where it returns from the outdoor unit. This will be hot and, or whatever, warmer. And this is going to the tank. So what I want the hot water to be entering the top of the tank. I want to be pulling the cold water from the bottom of the tank and sending it out and returning it hot, so that I'm not just, you know, reheating the same water. So either I need to pull cold water from here or the other side to get up to here. And then the hot water return is going to come to this one. And what I'm a little worried about is with this 1-inch PEX, I don't know that I'm going to be able to make a bend coming out here and connect down to here in that short of a distance. And then I'm also going to have this connecting down here. So I'll be coming out with a bend and then another one to connect up here. And it's pretty stiff, and I don't know if I'm going to be able to make that. And I also don't know that I love the having like a cross pattern, just for aesthetics. And then this one is pulling from the tank hot water from here, which again is a nice gentle thing. So I think I want to do that to help ease things along. I'm trying to use no elbow fittings if possible. You can kind of see now my plan. So this is going to go up against the wood like that, and this is so short here before that valve, but now I can, whoops, now I can cut it, you know, having that in the right place. I can cut this here and put the ring on and expand it, and not have to worry about trying to force this elbow on in such a tight spot. The other thing, I have these mounts here. So I think what I'm going to do, I'm going to put that on there. That just snaps on, and that'll hold it away from the wall. This is going to be insulated at some point, and this will help keep the insulation from being crushed, give me a little space against the wall. This will screw on. I just have to figure out where I want it, screw it in, and then I can put the pipe in. All right, well, I screwed that one up. I don't know if I didn't expand it. It was all the way down on the expanding head, but maybe I didn't do it enough times to keep the shape, or what, but that's as far as I could get it on before it stopped moving. I've got, you know, slack in the line, so I should have been able to get on there, but it didn't go. So I don't know if I can salvage this. I read in the manual you can cut off the sleeve, being careful not to damage below, but you still have to cut back 2 inches, and then you can try it again. But of course, if it's 2 inches shorter, it's going to be too short. So I think I might have to cut this whole thing off and try again, which kind of sucks. But this is a learning process. I'm sure by the time I'm done with this project, I'll be decent at this. I just redid that one. So I cut the ring off. It's pretty easy to cut that off. Cut 2 inches off the end. And I was about to do that over here, and I thought, you know what? Let me just try. So I took the bracket off the wall. I pushed the tank over a couple inches, and I redid this. I did it a few extra clicks, and that was the trick, the key. I just don't think I expanded it enough before. So this time it was definitely expanded better, slid right on, and it's where it needs to be. So I'm happy with that. And I think, you know, the tank is now like 2 inches closer to everything else. So I'm still gonna have like one tight bend in here, but I think overall I'm happy with the save. And now I know, you know, expanded a little bit more than initially it seems like it needs. So I've gotten the hang of the expander tool with this style of Pex, and I actually really like it now that I've kind of figured it out. It does a good job, super tight fittings. It is easier, like even 3/4 crimp rings take a bit of muscle. I couldn't imagine what a 1-inch crimp ring would be. I did this little section a 1/2 inch with the expander, and that it's no doubt is more flexible and easier to work with than the Pex-B. The other thing is you can, you know, kind of get it to shape, or, you know, to length, make your, you know, expand it, you know, off to the side, and then put it on. You don't have to have everything fully assembled in order to get the fittings on. So anyways, I really like that. I ended up leaving my components where I had them, and you can kind of see I angled my valves here. So I've got a little bit of an X pattern. I ended up reconfiguring this to put the pressure relief valve before the elbow, just to kind of stagger these here so they weren't going to interfere with each other. But I think that came out pretty good. I think it looks good. It's clean. And I'm ready to, I need to get the fan coils installed upstairs. That's, I think, my next step. I need to buy some wire to wire in my controls. I have everything I need to wire the pumps, and I have everything I need to get the main power out to the heat pump, but I need control wire. And then I gotta plumb the 2 main lines out to the heat pump. They're gonna go along this wall underneath the panel. I don't want any water above the electrical panel in case we have a leak of some kind. So these 2 are gonna come out under the panel behind this shelf. I think I'm done outside. Got the insulation on. It's pretty tricky. I got one last bit to do. I'm using 3-inch PVC as a sleeve through the wall, and it's pretty tight on this insulation. I've got to get this PVC tube up probably another foot. It's on the inside, so I gotta slide that up and get that in place. I'm just using a screw with a washer to hold it from coming out of the wall. I'm gonna caulk all around that, seal it up good. But the insulation, the pipe insulation, seals inside the 3-inch PVC really well, which is what I was hoping. If I had to do this over again, I probably would put these 2 lines, I'd flip them so they're one on top of each other, so that it could basically come together right into the house without having this like twist. But oh well, it is what it is. I also have stainless braided flex lines in here, which are pretty expensive. Those were like $50. No, they're like $100 a piece, I think. So $200 of flex line right there, and I don't think I needed it. You know, the Pex is flexible enough. I could have just got, if I wanted a coupling, I could have got a union right here and put the Pex right to there and save myself probably $150, which, you know, hindsight's 2020. When I bought the flex line, I wasn't sure what I was going to do. I was debating whether I was going to pipe actually copper out here to get it inside and then switch to Pex, but oh well. So there we are. These are the main feed lines to and from the heat pump unit outside. So those are connected. They run behind this shelf and they come up and they go out there. I've got the insulation run through. Let's see. The insulation is run through the wall. I'm using a PVC sleeve basically to go through my plywood and my wall and everything, and I will caulk around the PVC pipe to seal that up. The insulation seals really nice, tightly inside the PVC pipe, and then I'll continue insulating on the inside. This is the outdoor UV rated insulation. The inside will just have the regular foam that doesn't have the coating on it. So that's connected. I did have my local Arctic heat pump rep. So Arctic is the brand of the heat pump I bought. The local rep came out to see how things were going. Turns out this is actually the first system he's seen personally installed. He wanted to come out and just kind of see everything. When he was here, he pointed out a couple things that I could have done differently and or better. The first is this is a gate check valve, so that basically will swing down and stop reverse flow, but allow flow in the proper direction. That is unnecessary because the pump has a check valve in it. Over here, this is where the water will come out of the buffer tank and go over to my manifold for distribution to the different rooms. And I had a check valve in there. I had a spring check valve, this one here. This is a multiple, adjustable speed pump where basically I'll have this set to essentially hold a constant pressure. And then I have valves, zone valves for each of my upstairs units. There's a check valve in the pump already, and B, so the check valve in the pump will stop reverse flow, but it won't stop forward flow. And the forward flow is what we want to try to prevent. But because I'm using zone valves, these valves will be closed at all times unless there's a call for heat. So those zone valves will basically stop that phantom flow anyway. So I don't need a check valve or anything on the outlet of the tank. So I took that out. I have a change I need to make in the plumbing. I was thinking about how I'm going to fill this. And I have drums of 55-gallon drums of glycol water mix. And there's no way I'm getting those into the basement. They're just too heavy, and I don't know if I could even get it through the bulkhead. So they're staged outside right now next to the outdoor unit. And so I think what I want to do is I'm going to move the fill purge valve to outside so that is readily accessible right next to the drums, and I can pump it in out there. I have a drain in the tank down here, so I don't need another drain here. And the other thing that gets me is that outside will be the highest point of my initial fill. So I don't know if that helps, but it seems like it would help the air kind of migrate up. Okay, that's back together. New, slightly longer piece of PEX right there. Decided to start insulating my lines, and I'm running into a little bit of a problem. I thought I was being clever, and I bought these little standoff things. And yeah, they actually hold the pipe really well. Looks good, all lined up. I got 2 under there. The problem is that they hold this so close to the wall that I can't get my insulation behind it. Now I'm gonna have to cut some slots to go around here. The other problem is that I can't, these are too close together and I can't get my 2 pieces of insulation. I don't have a whole lot of room under there already. I'm digging into the corner with my electrical panel right there. It's important that the lines be insulated continuously so that when I'm in the summertime, when I'm cooling the water for air conditioning, any exposed surface is going to get condensation on it, especially down here in the basement where it's very humid. You know, a lot of this stuff I'm not going to be able to insulate as well as I would like, but that's just going to be the way it is. But I'd like to get my lines good. Okay, so I got that sorted out. I ended up moving the upper clamp for this upper pipe. I moved these up maybe 1 inch, and then what I did is I just cut a slit through the insulation, snap the pipe in, so both of those are secure and insulated. Obviously I have to still, this is a like a double seal insulation, so you peel off the yellow and it sticks together, and then you peel off, there's a backing on this tape, and then that goes over. So I got to do that, and then at every end, every butt joint, I have contact cement. So I need to contact cement the butt joints. But I'm going to do all that in one time because the contact cement's kind of nasty. So I don't want to be messing with it more than I have to. So I'm going to get all the insulation on, and like, see, I've got this here, but I've got to do all these butt joints as well. So I'll do all that at the same time. I've become aware of a problem. This is the tank that I bought with the heat pump. They sent some fittings, which included this nipple, adapters, the T, this vacuum relief valve, and this air bleeder. The problem here is that this vacuum relief valve needs to be installed vertically. It needs to be pointing straight up in order to work, as does the air bleeder. So they sent this T, and this is basically what I could come up with the parts that they sent to make this all work, but I'm not really sure what they intended me to do with all these pieces. I decided that I want to set the tank on something more substantial than just the ground. You can see it, I've got this 2x4 jammed under the edge so that I could spin on the test adapter, the pressure test adapter, because it was too close to the ground. And that got me thinking, I think I'd like to get this up a little higher. Now's the time to do it while the tank is empty. So I picked up a couple 2x6 pressure treated, and I made this simple base. It's just 30 inches square basically, so it'll fit under the tank. And then I've got these cinder blocks. I'm going to set the cinder blocks on the ground and then set the pressure treated base on top of the cinder blocks, and that will get us up, 6 inches or so from where we are right now. I think my plumbing fittings will still work. There's enough flexibility in these lines where, I can go up or down a little bit. as needed. One thing I may have to do, I think my pressure relief pipe will no longer be within 6 inches of the floor, which technically is a code violation. But I guess we'll see once we get it all together. I don't know if it's worth making a new one just because of that, but we'll see how it goes. Well, there we are. I like how it's sitting up like that. This seems a lot better. These connections will be no problem. I think these connections I'm going to have to actually remake these short pieces. I have to remake these short pieces here. This one's supposed to attach up there. This is supposed to attach down there. They're just too far off, so I'm going to have to redo those, but that's no big deal. It's, 4 feet of pipe wasted. I've decided to hold off on connecting these for now because I'm going to be expanding this system in the future to include more zones of the house, and I need to tie in a backup boiler. So if we lose power or the heat pump unit dies for some reason, we still have heat. So I'm going to prepare for that, and I'm actually going to add a T or maybe 2 to each of these. So I kind of have already the connections here. I think it's just going to be easier to do that now before the tank is full, because to change that, I've got to basically drain the tank down. So I'm going to make sure I have all my connections here. I've got a couple valves already, and I'm just going to get this prepared and basically have it valved off and probably put plugs in also just in case the valve gets open. But that will allow me to expand the system without having to drain 80 gallons of glycol out and put it somewhere while I work on the system. So I gotta get these parts, and then we will be back in business. I got the pieces to make my basically low loss headers, more or less. So this is, nothing's tight, but this is what it will look like. And then I need to disassemble this a bit and get some of these pieces to attach over here. So I'm going to be putting that together so that I can get this all reassembled. Where's this Hercules grip? I've been, the first time I used this on this project, but it works really well. I tried using it. Well, I've also been using Blue Monster tape, which this stuff works really well too. But this doesn't seem to seal as well on this large 2-inch material. I tried using tape and the pipe sealant, and that didn't work. So on the 2-inch fittings, I'm going to be using the pipe sealant. All the 1-inch, I'm just going to use the tape because it's easier and cleaner. All right, let's get this into the tank. Doesn't really matter which is top or bottom because they're the same. A little tricky to get this lined up. There we go. Alright, I'm going to call that good right there. Alright, let's rotate this up here just to stay. And then we'll get this one on. Okay, and then we can rotate this back into place. I'll go one more time around. All right. There it is. I'm gonna let those set up a little bit, and then I need to just attach my hoses back to their spots, and then everything will be connected again. All right, there we are, all connected. I did switch this to the top port and put the plug in the bottom. I'm leaving the insulation off until I can leak test this again. But I think it looks pretty good. What this will do is give me the ability to, when it comes time to add my other stuff on, I just pull the plug out, open the valve, and I'll be able to bring the next part of the system online without having to take the tank offline or drain it out or anything like that. This is a little bit of forward planning. Just added a little clamp here to hold that. That's really locked this all in. So I really like that. I'm back on the heat pump project after a couple month delay. But it's been raining today, and I realized I had an issue. I had these are going straight down, each of them, and the rain was running in and basically running along the inside and then dripping inside the basement all over the floor. So I just rotated these 90 degrees so they don't just collect the rainwater. And I might try to see if there's something I can put here to kind of just fill that gap. I don't know if it's caulk or something else, but I rotated those, and I just got my condensate drain poked through. So that's, the condensate lines are all done, and just finishing up some details before I fill the system.